No, it's empty.
Exactly.
Okay, and welcome to our weather discussion for this Friday. We have one more to go. That'll be next week. And then not again until probably after Labor Day, is most likely the case. If something really wild happens and people wanted to talk about it, as long as it wasn't me who did the talking, I'd be very happy to come. But otherwise, no. Second time this spring we had the aurora the other night?
I think so, yeah.
First time, of course, no one notified me. And as you might recall, I was quite upset by that. Having spent my whole professional life in this den of thieves, I thought maybe one of them would contact me, but no one did. But the second time, I did not suffer that fate. I got several different contacts. One of them was from Koshali, and I went outside, and I couldn't see anything. And then later on, I think you wrote to me and said, oh yeah, there's a little bit of cloudiness now. So if I'd gone back out later, I guess we would have seen some of it. And I can't tell, somebody told me something that seemed really dumb to me, that you could only see this well on a photographic device. I don't believe that. Is that? I mean, it doesn't make any sense at all. Almost everything else you take a picture of looks worse
The
than the
colors,
naked eye.
well, if you do a long exposure, the colors turn out better on
I could see that. I could see that, but you're not generally. That's not generally the case. But anyway, I guess it was a pretty good display and lasted a reasonably long time, right? Lots of people reported they saw it, and from all manner of locations on campus. So that's good. Imagine we didn't have so much light pollution. It'd be even better. Okay, so we don't need to see this anymore. It's been going. So we've got pretty nice couple of days in a row here, Thursday and Friday. It's not so bad outside now. It was really nice yesterday. But son of a gun, it looks like it's just going to be another week in the murk coming up. And I've tried to advertise that to my 100 students who are quite far behind, if you ask me, in terms of how prepared they are, just based on asking questions in class. They're not ready to take the final exam. But they'll have a week. They'll have a week where they're not ready yet. It's as simple as that. When you ask them, what direction is this, the apostle have to be moving to put a Coriolis force in the northern hemisphere in this direction, and they look at you like you have 3 heads. They're not ready. So, but they might get there. But it'll certainly help that the weather is going to be miserable next week, because then they'll have to be at the library or studying or doing something else. So we'll see that. Patrick will talk about the forecast, and I'll try and set that up a little bit. But let's start by looking at our satellite movie, Pete, over the continental U.S. So it's kind of an interesting non-developed scenario that we're looking at. We'll see when we go to 500 millibars. I don't know what happened there. But
Trying to get rid of that message.
there we go. We'll see when we go to 500 millibars that there's a broad trough occupying the eastern 2/3 of the United States, but it has a couple of little troughlets, little shorter waves within it. And they seem to be currently organizing some of the cloud systems that are over the continental U.S. One of them in particular focused across the eastern parts of Indiana, Ohio, and Kentucky, and we'll see that that's associated with a widespread region of light to moderate precipitation, maybe even some thunder in some locations, across the middle Atlantic, and then back towards the eastern Great Lakes, and a little bit offshore. And then there's another one that's a little bit less well-developed that is affecting the cloud development here in Kansas, Nebraska, maybe parts of Oklahoma and Texas as well. And that's about it over the continental U.S., and we'll see those reflected at 500 millibars, as I said in a minute. But look at the snows in the high elevations of the Rockies. And in even some locations, you can see here in Wyoming, it's receding during the day. So this must be on sort of plains, not on mountaintops, and a little bit lower elevation. But there's your snowpack. Snowpack in the Sierra is evident as well, and that's a record snowpack. So what we'd like to have is a cold spring to kind of gradually meet that out and have the use effectively be about the same rate as the melt. That is wishing for a lot, but let's wish anyway and hope that's the case. The same is true in the Cascades of both Washington and Oregon. So you get a really nice clear day along the coast. Beautiful day for looking at the mountains. In fact, I got a picture from a friend up in Mount Vernon, Washington, where they have giant tulip farms in the Skagit Valley. And so you can see the Cascades covered with snow and these blossoming tulips for sale over wide acreages. It's just absolutely beautiful. I remember going up there once, but it was cloudy the day we went. So pretty nice. Smoke in parts of Central America and southern Mexico. I don't know where they're originating. Perhaps it's in, is this Guatemala or Nicaragua? I forget what the country's going. Huh?
Nicaragua.
That's Nicaragua. So it might be smoke from fires in Nicaragua, although I don't know where it's emanating from. Okay, so that's a broad picture over the continental U.S. Let's take a look at the radar before we go to the upper level charts. And so here you can see, this is a pretty decently organized precipitation band that spreads, you know, it's more than 1,000 or 1,500 kilometers long, and pretty decent, probably widespread light to moderate precipitation across the middle Atlantic, Washington, D.C., Philly, New York City area, on its way to New York anyway. And then a little bit of precipitation to our west, which is maybe part of the broad northerly flow with a little trough we'll see in a minute over Nebraska, and that's maybe a focus for some of that there. And I think there's a boundary down across New Mexico and the panhandles of Oklahoma and Texas that has a forcing for ascent that's producing a little bit of precipitation, a little, maybe thunder north of Lubbock, Texas. Other than that, not too bad across the rest of the country, though it's cloudy in parts of the west, in Intermountain West, it doesn't appear to be precipitating anywhere, although maybe some of that's just a fact that we don't have radars that close together in that part of the world. Okay, let's take a look, if we could, Pete, at the 500 milliband. And of course, the eponymous Super Pete will do. So here's the 12Z from this morning. And so here you can see this broad trough over the eastern 2/3, maybe 3/5 of the continental United States. And I think embedded within it a couple of little short waves. Here's one that maybe looks a little more exaggerated when you go further down towards southeast or southwestern Colorado, but sort of a shortwave trough axis across this part of the Central Plains. Not too poorly correlated with the clouds and even some of the precipitation that we just saw. But it's a weak feature in the geopotential height, but a 90-ish degree wind shift across from southern North Dakota to the northeast part of its bordering state. And then there's another shortwave trough focused again sort of over southeastern Indiana, Kentucky, and then heading into Virginia, North Carolina. And that's really the feature that is tied to that precipitation band that's right here. In fact, strong cyclonic curvature and then strong anticyclonic curvature really produces strong upper divergence right in this location at 7 a.m. That's about where the band was. So it's really a nice fit for the large-scale synoptic structure there. But this is not well put together. It's a couple of separate but weak upper-level short waves within the context of a broader long-wave trough, and that even itself has a latitudinal distribution. There's a feature to the north over Hudson Bay that has, again, a couple of little ganglion in terms of upper troughs. So the whole picture at this particular moment is a little bit discombobulated, I think, in terms of organization. I don't believe it remains like that as we go forward into the weekend and early part of next week. I'll note that the temperatures are reasonably cold over Hudson Bay. We got an analysis temperature of -34, but the coldest OB is -32. So it's pretty chilly right over the bay, and it's not really much warmer over the northwestern archipelago. So a couple of places are a little bit warmer than -30, but broadly speaking, it's -30 over central and northern Canada, including the archipelago. And there's a big ridge that's built along the west coast of North America. So it does seem as though conditions are being set for cold air to kind of remain in this part of the country, the continent I mean, and then be ushered southward in this northwesterly flow on the eastern side of this ridge. And if that happens in tandem with the development of any one of these disturbances, we might find ourselves in a fairly gloomy coming week. And I'm particularly drawn to the temperature contrast that's analyzed here over parts of Alberta, British Columbia, and Saskatchewan. That's a pretty decent, that's a 10-degree temperature contrast at 500 millibars. And the temperature advection is hard to discern because the lines aren't particularly well drawn, but maybe one could analyze a model. If you've got cold advection in this region of cyclonic shear, then that's going to deepen this feature and turn it into its own upper level trough. And that might be one of the instigating factors that drives congealing of all of these separate features later on in the weekend. We didn't look at the West Coast satellite image, we'll do it in just a minute, but keep your eye on this sort of cutoff feature that's at about the latitude of the California-Oregon border, and that has a really nice signature in the satellite. And then there's a pretty deep cold air pool that's coming right off of the Aleutian Islands. This is -35, -34, -36 on Kodiak Island, so that's really cold air, and a pretty deep trough to the west of the disturbance that we'll see in just a minute on the West Coast satellite. Let's do that first, Pete, and then we'll come back to the upper level chart. Should have done that, but I don't mind that we went in that order, actually. That's probably a good way to do it. So here's the feature I was just describing, and it's right about at the Oregon-California border. and latitude-wise. And then remember, we had that cold air trough kind of coming straight southward over the Aleutian Islands, Kodiak Island being there. And here's the development downstream of that. And it looks a little more impressive even at this hour than it did 2 or 3 hours ago when I saved it for class. So that's turning into something rather substantial. Maybe it's even interrupting the cloud development associated with this thing, because this is getting a little bit more intense. But you can see how cold the air is, even in the infrared satellite picture. That's a lot of open cellular convection, and that doesn't happen unless the surface temperature, the upper level temperature is in the minus 30-ish range, and this is, we saw, probably a little bit colder even than minus 30. And the water here is not particularly warm, but it's still enough to get probably an absolute instability for saturated air fossils. And then further to the west, something churning here at about the date line, maybe even west of the date line, and then flow on the downstream side of that upper feature, which we couldn't resolve on the superpeats, pushing clouds and precipitation, presumably, certainly moisture, poleward towards the western end of the Aleutians. And sort of, I don't know, sometimes I call the ITCZ, it looks like a first grader's teeth with a few holes. This looks like a baby's teeth. There's no teeth at all. This is the teething ITCZ. There's nothing going on right now there, except one little patch at about 120 degrees west. Aside from that, boy, absolutely nothing going on across the Pacific, all the way almost to the date line in the region that's usually occupied by the ITCZ. So that's a highly variable feature, and I think it's fascinating how much it varies. And some of the new work that people are doing, including Angel and others in the department on, and Larissa back on the ITCZ is quite interesting, so keep your eye on that. Okay, let's go back to our upper level charts. And let's go down to 850 first. I think this testifies to how poorly organized things are in the eastern U.S. And I think, and the thing that my attention is drawn to is the lack of thermal structure here. And you can see there's a geopotential minimum that's sprawling. It's all over the Midwest and then comes over to the Appalachian states, almost to the Middle Atlantic. There's the minimum over Indiana, Kentucky, and that's where we saw the precipitation band in this region. But that precipitation band doesn't seem to bear any relationship at all to an organized phylogenetic circulation or organized temperature contrast across the very region where it's precipitating. And the only place where there's any sizable temperature contrast is down here, north of the Big Bend in Texas. It's 7 at Amarillo, and it's 20 down here near Del Rio. So that's a pretty sizable temperature contrast. And that's about it. A little bit of such a contrast also across parts of eastern Nebraska, maybe central Kansas, a little bit of southwest Minnesota. And we saw some precipitation in the radar that was kind of loosely aligned with that, although the advection is really a little bit funny. It's I guess it's strong differential advection. If there's any cold advection, it's carried by 30 and 40 knot winds, and then on the warm edge of that, the winds lighten to nothing. So that's a pretty good compaction of the temperature gradient that's implied by those winds, even though the direction difference is not large, the speed difference across the gradient is fairly substantial. And there's not much of a signature at 850 millibars of our feature that was spinning off the coast from the California-Oregon border. A more sizable temperature contrast is further to the north. That might be the 850 manifestation of the cold air that's coming down at 500 back to the west off the Aleutians. So that's got some connection, I think, to that comet, the leaf cloud that's developing to the west of the spinning cyclone off the California-Oregon coast. Let's take a look at 300 millibars next, Pete. So here's 300, which is interesting enough. I think what's going to be interesting to see is when we go higher, what does this thing look like? I have a feeling this is the underbelly of the subtropical jet. This is clearly the polar jet, and it's 158 knots right here off the coast of British Columbia, and or southern panhandle of Alaska. That's a strong jet, and it's riding the crest of the ridge, and so here it is coming back down to the south and actually turning a little bit to the southwest, which really does suggest to me there's going to be development over the Dakotas and Nebraska, because you've got not only anicyclonic curvature there, which will force a certain ageostrophic wind, but there's also the exit region of the jet, particularly to this point right here at 7 a.m. So I think we'll see some development of that northern feature. Not any obvious reason to expect continued development of the feature that's back to the east over Indiana, Ohio, and Kentucky. We may be misled because we might have hit this jet at the wrong level at 300 millibars. So that's the predominant polar jet. It's to the west, and it's poised to be the kind that can develop a substantial upper level wave over the northern plain states. I don't know if that will be the case, but it's in a decent position to set that up. Let's take a look at 200 feet. So we're going to go up now from about 6 miles to maybe like closer to 7 miles above the ground. And at 200 millibars, we see a little bit more intense wind speed maxima over the southeast states. So I think I was right that what we saw at 300 is the underbelly of the subtropical jet. It's rather stubby and not really well connected to anything that's further to the west. This might be somewhere north of the ITCZ. So this is a stubby little subtropical jet. This feature was 120 knots. At 300, it's 150 here, and so this is a continuation perhaps of the subtropical jet. Notice that we had our maximum wind speeds at a lower elevation, and this is now the upper portion, the sort of top of the polar jet that just pokes all the way to 200 millibars. So you can really see they're at different, the cores are at different elevations, and they're different features, and they're forced by different mechanisms. And at this level, this trough looks a little bit better organized. There's less of a hint of the feature to the east at 200 millibars, and there's a more well-developed look to this portion right down over the southwestern plain states, and in the position where in the exit region, one might expect ascent, cooling, heights, thicknesses falling, and so the heights will fall. And so this might be where we get the development of what we're plagued with over the weekend and next week. So, yeah, pretty interesting as it turns out for a not so well put together weather map across the continental U.S. I'll point one other thing out here. This is a region of warmest temperatures at 200 millibars, and yet it's coldest at 500. That's just because we went through the tropopause and we're now in the lower stratosphere. So you're going to have your warm bubble right there on top of your underlying cold bubble. There has to be a lens of high PV in between, and that shows up as the 500 millibar vorticity maxima as one manifestation. So all those things can be made sense of when one looks at the weather maps this way. I think that's all I have for the current weather. Any questions or comments? All right, Patrick, Beatty, thank you for doing the forecast.
Yeah. Can we go to the AOS looper of the QPF, please, Pete? So like Professor Martin said, it's going to be a pretty miserable weekend. Total, yeah. And if we could just make this as slow as possible, we'll just let it loop here. So I'll first draw your attention to the color shading. That is the liquid equivalent precipitation for this GFS model run, and so I'll let it run a couple times, but we'll pick out some bullseyes, mainly on the East Coast, but some locations directly to our north.
We get to the end, and it's not it's still generating.
So I'll point these out here. So there's obviously something pretty substantial happening. We have precip rates of 5 inches, close to 4 inches, 4 inches in a very wide swath over the eastern United States. And the contours are the pressure. And so what you'll notice is, I'll put my cursor once this restarts. Once this restarts here. Right in this location, northern Michigan, you'll notice this does not leave a low pressure system for most of this model run. You'll see there's a main low pressure system. It just lingers and lingers and lingers and lingers and lingers, and it dumps all this precipitation in sort of a comma shape, which would match a typical low pressure if one were just to move across. So we'll look at what is causing this broad region of low pressure to just persist right in this location and bring us clouds, cold polar advection from the north. Precipitation does not look to be too high for our location, but there are regions to our west and to our north that get 2, 3, 4 inches of precipitation. Some of this might be snow even. We can look at where the models think snow will fall, but there's generally a lot of precipitation for the East Coast forecast for mainly this weekend. You can see this is Sunday, Monday, and Tuesday, and then Wednesday is when this low pressure system slowly moves off over the ocean and we get high pressure and clearing and more warm conditions for our region. So let's go to the loop of 5.
One more time.
Oh, yeah.
It looks like there's 2 separate cyclones that get themselves put together. You're probably going to tell us that, I guess.
That's right.
You can see it even in the sea level pressure.
Yeah, that's right. I'll point it out while it's going here. So it starts with, there's a disturbance that will develop right over here. Here it goes.
And then there's the one
in the
over
north,
south.
and then there's one that is bringing severe weather to the south, and it swings up and moves right along, and they superimpose, and then they just linger over northern Michigan. So I'll point that out. There will be an easier way to look at it than this loop here. So could we go to 500, please, Pete? And we'll see why is it the case that that big, broad, low-pressure system just lingers there. Perfect. And I'll let this restart here. All right, so here's Saturday. We can see we're in a region. Could we make it a little slower, potentially? There we go. Okay. So I'll let this restart again. So we can see here's our trough moving over the middle part of the country. There's a pretty substantial system that moves over the southeast, and then it gets wrapped up into this large region of low geopotential heights that have little vorticity pendulums along it. And each time you have one of these little pendulums, I'll let it restart here. So we're looking up Wisconsin and Michigan. You can see these little pendulums move along. Each time you get synoptic scale lift downstream. And so you can just have this persistent low pressure system. You're constantly cooling the column, lowering the heights. This geopotential height minimum doesn't want to move because it's just persistent. It's just being reinforced right over upper Michigan until something else will come and move this along. And we can see there's a little piece that develops over Illinois, and then that's when you finally get the ejection of this piece. And I'll point that out again once it restarts here. So you can notice these little pendulums move along around this geopotential height minimum, and then something down here, right there, swings through, and finally this system can move off and we get clearing. So it looks like to be a superposition of two things. One, a system over the upper Midwest, and then the system that moves over the southeast. And the two swing around each other and superimpose around a central point, which is known as the Fujiwara effect.
Yeah, the
That looks
one
like
to the
what's happening.
north, sorry, Patrick.
Yeah,
The
go
one
ahead.
to the north starts like we might, like I thought it might, over the ridge. See that,
Yep.
going, that strong
Yeah.
vorticity development? That's an
Right.
upper front. So
Right.
that's
Straight
the,
from Canada, yeah.
exactly what looked like it might happen. And then that pendant, that long string of vorticity gets busted up into little features themselves. It's gonna be a beautiful satellite movie in the water vapor on Wednesday.
Yes, it will. There will
If
be a
it's very
massive
hot.
storm just sitting, rotating, probably not moving much, Monday, Tuesday into Wednesday before it finally moves off. So we might be, this is a might, regions in Minnesota, Iowa are in the clear. They're on the, there's supposed to be a very broad cloud head. I'll point it out here again. So just to the west, there will be clearing. It depends on when we get that clearing, when we'll start heating up. Because regions to our west will stay pretty warm, 60s, 70s. We'll be in 40s, some flurries, rain, on and off. Regions to our north will be snow. This may shift, but it looks pretty locked in since this location of this low pressure, or geopotential height minimum will not move that much, just based on this forecast loop. And we can go back and let's go to the surface loop, please, of the same look. We can see, we'll watch these two low pressure systems swing around each other. I'll let this restart. It actually becomes a pretty substantial storm, maybe even sub 980 hectopascal. Point that out here. So here's one system. The second one swings around southeast, and the two rotate around each other, become very broad. You can see all the color fill is precip. This loop seems to be a little faster than the other one, but let it go again. So you can see we just stay in a region of on and off showers. You can see the thickness becomes really low, especially over Michigan and into our region. Definitely cold enough that any precip might be snow. It might not accumulate, but it could be snow flakes falling for us. And definitely into southern Canada, maybe even the UP of Michigan, northern Wisconsin might get into pretty heavy snow and flow off Lake Superior. And we can look at this specific snowfall totals with that, but it'll be miserable.
If it doesn't snow here on Monday, it'll feel like it could.
Yeah.
That's what it's gonna be.
It might as well if we're going to be cloudy and 30s and wind and rain. So once this re-loops again, we can go to pivotal, please, Pete, and we'll look at the specific snow totals for our region specifically. See if there's any snow forecast to hit us. So let's go down to winter. And we'll do the 10-to-1 ratio. We could just do total snowfall. And we'll just click through here. So let's go to maybe 27 hours. So this will be tomorrow and Saturday. You can see there's already a bullseye of snow beginning to happen, maybe regions of Wisconsin, northern Michigan. Let's go now to 51 hours. Just keep stepping ahead. 24 hours here. So this has shifted since I looked. There used to be a bullseye that was swinging down over like La Crosse and the Twin Cities, but now it looks like it's becoming more north-south. UP, some of these locations are 24 plus inches of snow. You can see our region, maybe we get a trace. See 22 inches there. I think if we go, let's go to 75. This should be maxed out for snowfall. Yeah, 23, 31 inches of snow. There's a little mountain in northern Michigan that might enhance snowfall rates. So this probably is overdone, but I mean, it's not out of the question. You can see 2 feet of snow in some of these regions. This even has a bullseye for like very close to our region, maybe of 1 inch of snow. That might not all stick, but we might definitely see snowfall. And then we'll just go ahead, let's go to 99 hours. This should be where the storm exits, but you can see messy snowfall for much of the upper Midwest here. 30 feet from front. What is just slightly to the west? 35 looks like to be the winner. 45, there we go.
37, 45.
Yeah.
Oh my God. It's like an
And this is May, by the way. This is not winter, it's not January. So
No, you said 2 things that don't have to be untrue. It's May, but it is winter.
that's it. I mean, unfortunately, yes. So we'll have to watch, see if that actually does verify. And we can look, let's go to weather.gov now. That will lead me into my next point. Regions, especially to our north, do not need more snow. And so we'll click on the Duluth region here. And we'll go to Northland's seasonal snowfall records, the first one. And could we blow this up, please? So it turns out that Duluth, Minnesota has actually hit the record amount of snowfall for any period going back to 1885. So seeing, potential for 10, 12 inches of snow on top of a record in Duluth, where it already snows a lot, is pretty substantial. And we can scroll down here. There's other regions too. International Falls is not top 10, but Brainerd, Minnesota, northern Minnesota, Spooner, Wisconsin, pretty close. They might get into the top 2.
We heard from somebody from Bayfield the other day in class,
Yeah.
didn't we? Yeah.
Bayfield, I mean, is 32 inches
Come on,
above
let's get to
record.
200. Let's get to 200.
Yeah, it very well could get to 200 inches of snow.
Oh, that would be awesome. Their average is about 100.
Right.
Double their average, that would be
That's right.
great for them.
And then we'll go back one click, please, Pete.
Oh, man.
The caveat being, you get snowfall in regions that already have a ton of snowfall.
Yeah.
Flooding, especially along the Mississippi River, is going to be a big problem, and already is for much of these regions. And we can see that if we go back one click, and we'll go to rivers, lakes, and rainfall here. And is there a way we can make this screen bigger once it loads?
Oh.
I hope there's a way. Okay, perfect. And we can actually, yeah, that works. We can zoom into Wisconsin and Minnesota region. So these are a look of river gauges.
Wow.
The colors indicate the stage of flooding that the river is in, where, let's see, no flooding is light green, all the way up to purple is major flooding. And you can make out the Mississippi River here, going all the way down. There are 19 stations that are in major flooding. You put 35 inches of snow at the start of the river where it's already flooding, that's going to be a problem.
Yeah.
On top of it already is a problem. There are already regions in western Wisconsin that are flooding from this. So this will be something to watch as well. How bad does the flooding get? This might be historical levels of flooding.
Yeah, and it's destined to melt fast. I mean,
Yeah.
all joking aside about the weird snow on the 2nd of May, it's not going to stay cold.
Right.
After the first week of May.
That's
It's going
right.
to warm right up and melt away.
Right.
Wow.
So this will be something to watch, definitely close to home for our region.
Does this site allow us to see what the current height is of the Mississippi at St. Louis?
I believe we can if we find the station in Kentucky. We just have to make sure we're on the specific one.
Right there.
There we go. I think you can click on them.
Wow, there's a lot of them.
Let's see. Can we try clicking on it one more time? I know you can pull them out. Oh, there it goes.
So they're at 21 feet?
That's a
Okay.
forecast.
That's a
Oh,
forecast.
it's a
They're at
forecast.
17 feet right now.
Okay.
And it doesn't show usually these show the levels of flood stage.
Okay. Their record we just saw in Class A is 43 feet.
Okay.
So they're nowhere near that. I thought, there might be a surge from this
Oh.
extra snow.
Ah, there we go.
It's 90,
But I mean-
93, 49.6.
As this, rivers move pretty slow, so as all the flooding and snow melt continues, this might increase.
Yeah.
I wonder if there'll be another maximum down here. Well, let's go back to the map, and we can find La Crosse, I know, is under the gun. That will load, maybe? We're gonna try going back one click. I think we have to.
It just has to reload.
Okay, yeah.
Maybe you're right.
I wonder
It's
if
only
they-
loading the one sound you're saying.
Yeah. I wonder if we just click the river observations again. Oh, okay, click that. There we go, this one. So I know La Crosse is expected to get near historical flooding. We can actually look at that.
Sorry.
That's great. So let's see, what are these red locations? We'll do it for us. Click on it again. Okay, so right now, they're already in major flood stage. They're about 2 feet under the record, but
Wow.
this is a forecast, so if the model's verified and you do get 35 inches of snow directly upstream, this might, increase. We might have
Yeah.
near record flooding for 19 states, or 19 locations along the Mississippi River, so a widespread flooding event looks likely for our region. And then one last website I want to go to, could we go to, just search latest snowfall in Madison, Wisconsin. It'll come up with the website here. Perfect, right here. So this is extremeweatherwatch.com. I'm not sure how valid these data are, but we want to scroll down. This is a look at the latest snowfall. If we get snow, we're sitting at top 20 latest snowfall in the history of Madison's record here. If we get 1 inch of snow, that'll be substantial, because most of these are just a trace of snow. There's some like 4.8 inches of snow. May 3rd, that would be terrible. April 30th, 8 inches of snow.
Look at May 10th, 1990, that's a 3-inch event.
Yeah,
That's really
right.
that's an outlier. That's way out there.
so we're definitely near record territory. We're not going to set any crazy records, but definitely a
We
noteworthy
don't know,
event.
we don't know that yet, though.
That's right. Yeah, who knows what's going to happen
Yeah.
middle May, so.
But we're over 70 for the year, aren't we?
Yeah,
We
that's
think
right.
we
I
are,
think we're
which is-
72 inches of snow.
That's pretty high. That's in the,
Yeah.
I'd probably in the top 10 percentile. Or
Isn't that
90%
about
of the
double
top
what we
10%.
normally get?
Yeah, the average is, I think, 40 or
That sounds
44
right.
or something.
Yeah, here's our snowfall.
So, yeah, 72?
72.
So we might get 73, 74 after this event, which is pretty substantial. You can see how much different this snowfall is compared to the average.
Yeah, it's all the month of March.
Yeah,
Boy, oh boy.
two storms.
Everything was normal till then.
Yeah.
That's how you have to think about it.
So miserable weekend, much like Packers fans after the kick last night.
At least
I'm a
that's
Vi-
temporary for us,
That's right.
not for you.
The pain lasts as a Vikings fan.
Yes, it does. That's a permanent condition.
Yes, it is.
You guys can't even
You
get
live with it.
insurance.
You
can
live with it.
Yeah.
So any questions or comments about anything I showed?
No, thanks, Pat.
Perfect.
All right.
Thanks very much. Thank you, Pete. Forecast.